Unpeeled. Today, we start with a rapid unit that is helping the United States Air Force use 3D printing. So at Ogden Air Logistics Complex, there's an Air Force kind of MRO tooling unit called the 809th Maintenance Support Squadron. And they're called RAPID, or part of that squadron is called RAPID. And they're called Reverse Engineering, Advanced Manufacturing, Prototyping, Innovation, Design. So what they essentially do, they have CAD services, 3D scanning services, and print services. And they offer this as a shared service for the base they're at and a bunch of other bases in the Air Force. The unit has over 20 3D printers. They have powder bed fusion, they have powder bed fusion metal, they have FDM, they have SLA. They reverse engineer parts that are out of production. They print spare parts. And what I thought was a nice tidbit is that they also make tooling. And especially in the military sense, we notice a lot of focus on the printing of spares, but not a lot of focus on the printing of tooling, which of course you could use to do so many more, and a lot of times also so many more cost-effective parts in a lot of cases. So far, they have saved the Air Force over $1 million, and they tend to save like 12 to 15 man-hours in every single project they work on. They do, well, the kind of like what you would expect stuff, but also things that we may not expect, like parts for fit checks for aircraft. It's the aircraft, it's a kind of check the pilot has to do when she accepts an aircraft. Every time she takes over command of an aircraft, she has to walk around the aircraft and accept it and do a kind of a series of tests. And they make parts for this, for example, which is a very kind of unique case I hadn't heard of yet. They also just do polymer parts to then do a kind of a dry run fit test, and then they print it in metal later, which I think is a great practice to do. And they're spreading their kind of like influence and their service to more and more air bases in their area. So what a lot of people are seeing is this idea to have a competence center to centralize additive manufacturing. And the military has done this. And like, for example, the Air Force, we talked about this a couple of days ago, the Navy, for example, has one central training authority to train people on 3D printing. That also makes a lot of sense. But a lot of companies make the mistake, I think, of doing just one competence center. Like there's only one group of people, and these 10 people, those are the additive people in an organization. Now, in an organization as vast as the United States Air Force, that does not make sense. Right? You need different people with different approaches in different regions, right? And it's nice to see that the Air Force has this area, right? This is Wright-Patterson, I think they are. There's another unit doing a similar thing in Hawaii. There's units doing some stuff in Japan. So we're seeing a kind of spreading out. There's more competence centers, competence nodes, if you will, kind of expanding their tentacles into this organization. I think that's a really great way of spreading the technology. Also, think of just this possibility of how big this market is. This is a picture you see of a Air Force staffer who's taking a part from a print bed using an amazing kind of spatula instrument, by the way. And we can see just in this picture, we can see a 450 MC, a 900 MC, a couple of iPros. I think that's an RPS system. I'm not sure. Or Stratasys Neo thing. That's a lot of printers, a lot of fairly recent printers in one unit, right? Imagine the possibilities for the rest of the Air Force. Now, to put this in perspective, a lot of people are looking at, oh yeah, we're thinking about working with the U.S. Defense Department. We're thinking about this area. The Air Force, spends $81 billion on maintenance, right? And $53 billion on supplies and materials. Now, a lot of that, of course, is jet fuel and like things like really expensive radar components, right? But that market in and of itself is much bigger than, I don't know, the Dutch market for additive manufacturing. The U.S. Air Force market for additive manufacturing may be bigger, in fact, than that of several different countries, right? So I think this is, especially if you're an OEM, I don't think it's optional to have a U.S. government kind of like salesperson or engagement or kind of like a wish to engage these people, just because the market is going to be so huge, right? And I think that's something to look forward to. And generally, I think this is really best practice and really, really a good implementation of doing here. The next thing is Novineer. And Novineer is a software startup. It comes from Embry-Riddle Aeronautical University, where it's from Dr. Ali Tamijani, or Tamijani. Sorry about that, but he's a professor of aerospace engineering He's on the right in the picture. And on the left is Zhixiao Wang, who is his student. And both of these gentlemen started Novineer. Novineer has been aided so far by an NSF kind of program called I-Core, and also a bunch of startup competitions the two gentlemen won. So that's a really good thing. There was actually it's a third person whose name I forgot, but there's a 3-person startup at the moment. And it came forth of a project from the multi-material metal printing at NASA. There was also a simultaneous project that was a composite 3D printing for the Navy, and a lattice work project for the National Science Foundation. Now, all these projects kind of came together in Professor Tamijani's head, and he kind of figured out to do a software that combines all these. And you think, well, these are pretty disparate projects, right? But he saw a path to streamlining this to kind of accelerate software development. And what he was looking at was like design of experiments, design, simulation, mechanical characterization, all these separate things that are now considered to be separate, that are now done in separate software packages, separate steps, now require you to have a CAD package to iterate. Then you do a design of experiments. Then you do kind of, for example, you do a simulation. And then maybe you would characterization would be something completely different that someone else in the organization has done. Now we're finding out that we said this many times before at 3dprint.com, design for additive work or engineering for additive manufacturing is a team sport. You have to have an integrated team working together on all of the challenges, all of the parts of this development, because it's not something that one person get their head around. It's not something that influences just one person's area, right? So it makes sense then to have a software package that does all these things in one. And indeed, the team say that they have certain things that would take 40 hours with other software packages that could be done in 4 hours with them, right? Now, essentially what they're doing is they're doing optimization of structures and optimization of 3D printed files in one package. So they're integrating the modeling, design, simulation to a certain extent for a lot of that 3D printing supply chain bit. Now, this is something that a lot of tools are kind of sniffing at this possibility. We've got Amvis, which is doing this to a certain extent. Toffee AM is doing this for a certain extent. And there's no extent, if you do listen to the show a lot, you'll see that I keep coming back to these edge software cases, because what we're seeing is CAD, right? And what the CAD vendors like the Siemens is and the Autodesk and the SolidWorks and Dassault's are doing is they have a base package that's already quite expensive and often, and they keep layering more and more functionality on that, like more and more functionality. Oh, you want a module for simulation? Oh, we can get you this. Oh, you want a different kernel? You want a different kind of service? We'll layer that on top of you. We'll upsell you. Meanwhile, to the company, all right, your Boeings or your Fords, they'll say, we've got PLM that fits in like seamlessly with our, I almost said needlessly, but seamlessly with our authoring, our CAD package, right? So they're trying to do an upsell of that base kind of subscription model. That's kind of the way that everyone's kind of looking at this now. So a company like Novineer, which is essentially saying, look, guys, we're going to be doing a lot of that key cutting edge work, the tip of the spear work, right? The really valuable stuff where we're going to make your rocket engine a bit lighter, where we're going to make that texture of your medical device better, faster, so that it is better at also integration. We're going to do that in our package. So what in essence they're saying is the cutting edge engineering, the cutting edge additive manufacturing software development stuff, design development, the new textures and geometries for the new generation of parts, we'll make those. And then, yeah, you can still do your CAD stuff. And so essentially I love this, and I love all the companies that are doing this, and all the software companies that are kind of basically claiming the most valuable island in simulation and software land. And think about all the exits, and think about all the companies like Ansys and Autodesk and stuff that would be lining up to sell to buy this company if it's successful. So I love this very much. I think it's a great idea, great startup. The next thing is, this caught me by surprise a little bit. You've probably heard about these 3-in-1 3D printers, these 3-in-1 desktop 3D printers. There's a bunch of them out there right now. Some of them are 4-in-1. What most of them end up doing is taking a standard Prusa type i3 type of 3D printer, and they add a laser engraver on top of it. And I've always kind of been really skeptical of these things. I don't have one, and I have most other the desktop type printers, but I don't have like one of these. I never really thought it was like for me. I thought if I want to do a laser cutter or if I want to do laser engraving, I'll buy like the best laser cutter, right? And I don't want to have this like multiple tool thing. I've never really considered it for me. If you make one of these things, you want to give one to me, convince me otherwise, totally, totally. But just so far, I just haven't really thought of getting one or even reviewing one. Now, right now, all of a sudden, well, there's something really, really exciting that's so obvious, that's so brilliant that you're some of you are gonna like knock your head on the desk while you're reading this. Now, essentially, there's a Nature publication, Nature paper, and Nature publication called Scientific Reports by a couple guys from people around from Pusan National University, Sajal Chakraborty, Hoyol Park, and Sunyan. So they've taken one of these 3-in-1 printers, a desktop unit that's about $950 or something. I just checked the price. It's called a Mooz2 by Dobot, which I wasn't familiar with actually. And this is one of these, Jans, it's one of these laser engraving / 3D printers. Now, what the guys have done is something you're gonna like. Some of you are gonna be, oh my god, I don't believe I didn't think of this. So they've taken a polyimide or PI kind of substrate, kind of film, and they've used this thing to etch onto this substrate. Then they use a camera on the 3D printer to characterize essentially and to get the right focal length, right? So they're using this really, really inexpensive system to essentially make circuits. And they cut these circuits and they wash them afterwards, and also they put a precursor and then wash them all this. This is comparable in resistivity to the copper and a glass substrate, which is very, very good. Now, with the washing process, it kind of reduces some of that. But what the team found is that they were able to, and you can see in the next picture, you can see on the right-hand side the skin. And on the skin, they have this polyimide, the PI, which is like Kapton is another, DuPont Kapton is one of there's a branded polyimide thing. And you can see these etched substrate kind of like filled in kind of circuits working to power lead on top of the skin. So what the team thinks is that these really inexpensive printers could be used to make like biosensors, flexible electronics, bioelectronics in a really, really cost-effective, really kind of accessible way. So I think this is absolutely fantastic. I think the creativity needed for this, and to do something so wonderful with this, and to showcase that but this is just like one. I haven't seen anything like this using one of these desktop printers in this way, and I think it's fantastic. I think there's many more things possible if more researchers look at this. So this just completely blew me away. So the guys at Pusan University, great work there. Thank you so much for your time. My name is Joris Peels, and this is another edition of 3D Printing News.